welcome to codezing.org. We got another project. I think this one's going to be a lot of fun. It's a level 2, and it's rock, paper, scissors. So everybody loves to play rock, paper, scissors. I do, at least. So you can find the code at codezing.org/rock_paper_scissors. Probably easier than typing all that in is just go to the website codezing.org, level 2, rock, paper, scissors. Alright, so make a choice, rock, paper, or scissors. And I picked rock. Computer picked scissors. I won. I'm great at this game. Oh, I won again. I'm on a roll. 3 times. 4 times. 5 times. 6 times? This is a little silly. Oh, computer wins. Alright, finally lost. I thought I was the rock, paper, scissors master there for a little. Alright. Alright, if you never played before, rock beats scissors, scissors beats paper, paper beats rock. And those are the general rules. So you can pick from the 3 things, the computer will pick from 3 things, and you have a set of rules for who wins. So let's grab the code down below. It's a little longer code, but it's kind of simple. It's a little repetitive. So it looks long, but it's not so bad. Open Spider, pop in our code. What do we got here? So our first thing is import random. So we've talked a lot about import statements, getting additional libraries, additional functionality by importing additional code. So we're using random, and that's going to be for making the computer's choice. This is going to be a random pick between rock, paper, or scissors. Before we do the random pick, it's going to ask for the player's choice. Right? Enter your choice, rock, paper, or scissors. See how that works. Let's do paper. I won. I picked paper, computer picked rock. Cool. I am very good at rock, paper, scissors, I guess. Alright, so the player's choice, it's just going to receive whether you type in rock, paper, or scissors, and it's going to make that equal to player choice. The computer choice, like I said, is going to be random.sample, and then within the random sample function, we have a Python list, and this list is the possible choices that the function is going to run on. So the random sample is going to choose from those 3, and I'm only want it to choose 1. Random sample, obviously, you could have it choose more, or you could make the list longer, but for this game, 3 choices and 1 sample. And then it sets computer choice equal to computer choice 0, and that's just because random sample usually expects you to sample more items than just 1. It's usually used in like statistics, and you want to sample a big sample. When you're just sampling 1, it still returns it in a list. So to get the first item in the list, you need computer choice, and you want the 0th, the very first item. So if we did print computer choice, you will see that what it gives you is this. It gives you another list. And then I'm going to try to make comparisons down here with if statements, and I can't compare the text rock to a list. I need the value in the list. So computer choice 0, resetting computer choice there to make sure it's just the text paper and not the list paper. The next is a series of if statements. We've covered these in a couple of the other lessons. So it's just going to test if the player choice, and this is 2 equals, which is the test, kind of like is equal to, 1 equal sets the variable to the value. So this one sets computer choice equal to computer choice 0. If you got rid of the other equal, that means that you want player choice to equal the computer choice. This is the test with 2 equal signs. Does player choice equal computer choice? And if it does, so if you pick the same thing, the result variable is going to be equal to you tied. And then the next if statements just run through all of the possible permutations of who picks what and who wins and loses. So if the player picks rock and the computer picks scissors, then the player wins, you win. If you pick rock and the computer picks paper, then the computer wins. And then obviously if you both pick rock, that's covered up here with, and you would tie. If player picks paper, computer picks rock, the player wins. If the player picks paper, computer picks scissors, computer wins. And so on through scissors, and that's it. So it's just going to step through one by one until it finds the correct result, or the result of the game. Right, so it's going to receive the player choice, pick a computer choice, and then run through all of the if statements, and when it finds one that's true, it will set the result equal to the text string that I typed in here. Down at the bottom it prints out the result, like there, you tied, and then at the bottom it gives you a little bit of feedback of what you picked and the computer picked, because if you don't print that out, then the player sees the result, but they don't know what the computer picked, they just know whether they won or lost, and it doesn't really give them much information. So this is a print statement in the format that we had covered in one of the other lessons, but not the simplified way to print things out. So this is the text string you picked, and then the curly braces, computer picked, and the curly braces, and then we're putting in a dot format. And within the dot format, we're putting the variables that we want to go in the curly braces. And Python just matches up the first item with the first bracket, second item with the second bracket, and fills them in. If you like the other way that I had done it previously, you could print it as you picked, and then player choice separated by a comma, and then we're going to want a space in there, computer picked, and computer choice. So those are the same. They'll do the same thing. Dot format is a little more powerful, and we're trying to coax you into switching to dot format instead of doing it this way. This is kind of the more correct way to do it. But this will work equally as well. It'll print out the same thing. Let's run it one more time. Make sure that's true. It should. Let's print that out. Let's see. Paper. And it does. I forgot to put a comma somewhere in my text. I think if I would have put a comma there, it'd be exactly the same. But you can see it printed out the same thing. Alright, what else? Oh, these AND statements. That's kind of glaring right in the middle. I don't think we've done an AND statement before. So this is when you want it to be a compound test. Like do two tests at once and they both have to be true, is an AND. If you want just one of them to be true, then you can put OR, and it will test if player choice equals rock or computer choice equals scissors, then do something. But that's not what we don't want, an OR. We need it both to be true, right? If the player choice is rock and the computer choice is scissors, if both of those are true, then the result equals you win. And we can, let's see, why don't we print out let's see, print the player choice, that's right, player choice, and we'll just print the computer choice so you can see the computer's picking at the start. Let's see, so we'll pick rock this time. You can see, so we printed the computer choice, which was the list I was showing you, that it gives you a list and you need to convert it. Now it's doing print player choice and print computer choice. So rock, and it gave us you tied. So you tied is this first one, right? It's the simple, if player choice equals computer choice, then the result is you tied. And it doesn't have to look at any of the others, because in none of the other cases are they equal. So it just skips through all these others. It does the test, it comes back false, and it moves on to the next test. But that's what this AND statement does. It has to both be true. If either one is not true, if player choice is not equal to rock or computer choice is not equal to scissors, then it will make the entire if statement false and move on to the next if statement and won't run the code below. Alright, well, feel free to play around with this. I think one of the interesting, you could always change change the names. Like maybe you did I don't know, you want stick, I don't know, a hoop, and a bomb. I don't know what you could do. All right, so we'll make all of these rocks stick instead. Did I get all my rocks? I think so. All right, and then all my paper. It's going to be hoop. I don't even know what a hoop is. What did I think hoop? Paper, and then scissors. Scissors always seemed a little dangerous for the game anyway, but I guess replacing it with a bomb is not much better. Alright, so we got rid of our rocks, our papers, our scissors. And now we have stick, hoop, and bomb, and we would want the user now to enter stick, hoop, or bomb. And now, I just created a brand new game. Nobody's ever played it before. Stick, hoop, or bomb, and the computer wins because they picked hoop, and obviously a hoop would beat a bomb. Oh no, they picked bomb. Alright, so bomb beats hoop. That makes sense. Bomb should beat hoop, I think. Let's see. Well, I'm going to pick bomb. The computer won again. I guess a stick beats a bomb. Alright, anyhow, so you get the point. You can come up with any three things you want and replace the words, make the game however you want it to be. You could add a fourth choice if you want, but that's gonna lead to a lot more if statements and decisions about who wins in which particular situation. You could do just two, maybe, but that's kind of like a coin flip. Three's probably the right number. Anyway, have fun with it. If you think of a cool one, you can email it to me at info@codezing.org. We'll post it to the site and other people can see what you've done. Yeah, I guess that's it. Have fun with it.